Hi, and welcome back to Neural Data Science. Today our lesson is on Python dictionaries. The questions we're addressing are how can I organize data to store values associated with labels, and how do I work with such data structures? So our learning objectives are to be able to store data in dictionaries and to be able to retrieve specific items from dictionaries. All right, so dictionaries are a particular data type in Python that is a mapping. And I'll explain what that is in a minute. So they're collections, just like lists or strings. In other words, they're storing multiple values. But they're mappings in that, like a traditional dictionary where you would have a list of words and each one is associated with a definition, in a Python dictionary you have keys and each key is associated with a value. So essentially the keys are labels that we give to the values, which makes it possible to access those values through their keys. Dictionary is defined using curly braces, as we see in this first example, and then we specify the key value mappings using the colon. So for example, I'm going to define a dictionary called my_info, assignment operator equals, then I open my curly braces, and you get the curly braces by holding down the shift key and pressing the square bracket keys. All right, so the first key in my dictionary is going to be a string first name. And so that's enclosed in quotes, and then a colon. And then again enclosed in quotes, because it's another string, is the actual value, the name that I want to store as the first name in my dictionary. And that's Aniki. Oh, little typo there. Okay, I'm going to hit enter. And again, it's nice to put each entry on a separate line for clarity. Oh, and the other thing is after that first dictionary entry, I need a comma. Okay, so now my next dictionary entry is going to have a key of last name, colon, and then a value of Bogdana. Use a comma to separate that dictionary entry from the next dictionary entry, which will be age is the key, and the value for this is 15. So you can see here that like lists, dictionaries allow you to store different data types in a single data structure. So our first two keys and values were both strings. For the third entry, our key is a string, but the value is actually an int. And then finally, our fourth entry is going to be height, and that's going to be a floating point number, 1.66. All right, so I can run that. And now I've stored all of those dictionary entries in the variable name myInfo. Now, the dictionary keys have to be an immutable type in Python, meaning you can't change them. Once you've defined a key, it's set, and you can delete it, but you can't actually change the key. So the keys have to be things like strings or numbers, such as ints or floats. This is because the dictionaries are organized by these keys, and it throws everything off if you try and rename the key later. The values, though, can be any type, including, as we'll see later, the value of a dictionary entry could be a list or another dictionary even. So anyway, the values in a dictionary are accessed using their keys inside square brackets. So before with lists, we saw that you would use a similar sort of syntax. So you give the name of the dictionary, myInfo, and then square brackets. But whereas in lists, you access by the index, the position of a particular item within a list, with dictionaries, you access them by the keys. So we give it, say, first name, hit enter, and we get Aniki is the value associated with that key, first name. Okay, so we already have lists. Why would we need dictionaries? Well, the thing about lists is that they don't have labels for the data. So in this example here, you can see life expectancy. So these are the life expectancy values for Canada across the 20th century. We have a list of values, 48.1, 56.6, etc. But we don't know which year is associated with which life expectancy value. So we would have to know that information from some other source. Whereas dictionaries provide us with a nice way of having all that information in one place. So we can say life_exp equals, open our curly braces, and then give it our first key. Our first key is 1900, so that's a year, basically labeling our data. And the life expectancy in Canada in 1900 was 48.1. Then for 1920, the life expectancy was 56.6. For 1940, the life expectancy was 64.0. For 1960, life expectancy is 71.0. For 1980, the life expectancy is 75.2. And finally, for 2000, life expectancy is 79.2. And you can see that in this case, all of my keys are integers. I didn't put those in quote marks, so they're not strings, they're integers. And all of my values are floating points. So run that cell. That's now stored in life exp, and I can access the life expectancy for a particular year just by using that square bracket notation, life exp square bracket, and then 1940. Okay, so that works as long as the key actually exists in the dictionary. If we were to ask for a key like 2021 that doesn't exist in the dictionary, we get a key error. So in other words, Python's telling us there's no key called 2021, so it can't give us a value, it gives us an error. Okay, so dictionaries are mutable, meaning that they're modifiable or changeable. So we previously talked about immutable types like strings, where the contents can't be changed, and mutable types like lists, where the entries can be changed. So dictionaries are immutable in that you can change the values associated with entries, and you can certainly add more entries or delete entries. But we just can't change the names of existing keys. So here is an example, life exp 2020 square brackets equals 83.2. So what I'm doing here is I'm adding a new dictionary entry, and I'm assigning a key of 2020 to a value of 83.2. And now if I ask it to print life exp, run that cell, you can see that now we have all of our previous values, plus we now have the 2020 equals 83.2 mapping that we just added. We can also change the value of an existing entry, again, through the same assignment operation. So life underscore exp square bracket 2020. So here I'm going to change the value associated with 2020 from 83.2 to 82.3, just by doing 82.3. And again, print life exp to confirm that worked. And you can see in doing that, Python didn't warn me that I'm overwriting an existing dictionary value. So you do have to be a bit careful that you are not unintentionally overwriting entries that you already had in the dictionary. But as I said, the dictionary keys can't be renamed. So imagine we wanted to add another life exp value for a new year, and we forgot that we were using integers as our keys, and we made this key 2040 a string. We'll assign it a value of 85.1, print life exp, fix my typo, and now you can see all the other keys are integers, but this one's a string. So I can't actually change that entry. So if I wanted to add a proper entry with an integer as a key for 2040, I would have to either do what you see here, which is just assign 85.1 to a new dictionary entry with the key as an integer. Or equivalently, I could do this and say life underscore exp 2040 equals life exp square bracket quotes 2040. So basically now what I'm doing is I'm copying the value that's stored in the 2040 as a string dictionary entry to a new dictionary entry where 2040 is the key, but it's an integer. Print life underscore exp. So now you can see that I have both a dictionary entry with 2040 as a string, as a key, and a second dictionary entry with 2040 as an integer, as the key. So we now have both. So we can copy a value from another dictionary entry, or we can just manually enter a new dictionary entry. But to get rid of that erroneous one where we used the wrong key, we have to actually delete that. So one way of removing a dictionary entry is using the del statement. Del in Python is a statement, meaning that you say that, or you type the name of the command followed by a space, followed by what you want to delete. So you can see here, and I'll have to add a cell below here to type this. Oh, come on, add it below. There we go. So we're going to del life underscore exp square bracket and then the key in quotes 2040 and then print life exp. And I had a typo there. You probably saw it before I did. There we go. Okay, so now we have 2040 key as an integer, but we're not seeing the one where the key was a string. We've deleted that, so that's great. We can also remove dictionary items using a method, which is .pop. So here what I'll do is I'll first create an incorrect entry. So life exp square bracket 200 equals 79.2. Print that just to confirm that it's added. And then I'm going to remove that entry and print it again. So life exp .pop. And with .pop, the argument to the method is the key of the dictionary entry that you want to remove. So remember, methods are like functions in Python, except the way you run them is you give the variable name that you want to operate on, in this case the name of the dictionary, a dot, and then the name of the method pop, and then parentheses with any arguments for it. So in this case, the argument is the dictionary entry we want to delete. Then we say print life underscore exp. Okay, so you can see the two outputs here. The output of the first print statement shows this erroneous dictionary entry of 200, mapping to 79.2, and then the second line shows that the .pop method did in fact remove it. Next thing to know about dictionaries is that they are unordered. So strings and lists are ordered, right? So strings are a sequence of characters in a particular order, and lists are a sequence of values separated by commas in a particular order. And we can access specific items within a string or a list using indexing, starting from 0, 1, 2, 3. We can use those integers to access specific positions within the list or string. That doesn't work for dictionaries. Dictionaries don't store their key value pairs in any sort of particular sequence, and critically, you can't access them by a positional index like 0, 1, 2, etc. So in this case, life underscore exp square bracket 0 doesn't give me the first entry in the dictionary. It gives me a key error because when you use the square brackets to refer to a dictionary, it interprets what you give it inside the square brackets as a key, and it looks through all the keys in the dictionary. There's no entry for 0, so it gives me a key error. So that's just a difference in the way dictionaries and lists are organized. Dictionaries have other properties though. So they do have a length. So we can use the len function on life exp, like we could use it with lists. And the length is 8. So that's 8 keys, 8 dictionary entries. Another thing we can do is we can ask just for the keys using the .keys method. So life underscore exp .keys, parentheses, it doesn't take any arguments. And here you go, you can see our keys are 1900, 1920, etc., etc. Likewise, you can view all the values, life underscore exp .values. Run that, and you can see just the values that are stored in the dictionary. This can be particularly useful if you have large dictionaries with lots of entries and you want to see them without printing out the entire dictionary. There's also a method to get items, life underscore exp .items. What this does is it prints out the key value pairs, but each key value pairing comes out as what's called a Python tuple. So it's a pair of values, in this case, inside parentheses, and they're separated by commas. And you can see here that each of these outputs, so the .keys, the .values, the .items, all of them are specific types, the output of them. So dict keys, dict values, and dict items. But each one of those actually contains a list of the particular keys or values, etc. And that's something that we can use later. So the output of .items is, again, these sort of key value pairs inside parentheses. And again, this becomes useful later, especially if you want to do things systematically to each individual entry in the dictionary. We'll see this in future lessons. And there's a skill testing question here I already answered. What type of are the results of keys and values methods? So there's specific dictionary-specific types, dict keys, dict values. But again, the value in there is actually a list. Okay, so another thing we can do is find whether a particular key exists in a dictionary. And we use this using another Python statement, the in statement. So if I want to check if 1900 is a key in the life expectancy dictionary, I just say print 1900 in, and again, in separated with spaces, life underscore exp. So that one is actually true, right? We did have an entry for 1900. And I'll do also print 1800 in life exp. We know that one doesn't exist. So we get a result of true for the first test. 1900 is in fact in life exp. 1800 is not, so that is false. Now, of course, if your dictionary is small, you could just print out the dictionary and look at it. But if your dictionary is large, this can be a useful way of finding if an entry is there or not. And when you're actually coding, you often want a way to sort of do coding to test if something's true or not, to see if an entry is there. So you could imagine saying, like, if a particular entry is there, then we want to do something with that. And again, this is something we'll cover in future lessons. As I already mentioned, dictionary values can be any type. So there's restrictions on what the keys can be, but the values can be any type, including collections like lists or other dictionaries. So we're going to define international life expectancy as a new dictionary, and we're going to give it 3 entries. The first one is for Canada. And as the value for the dictionary entry for Canada, we're going to give it a list of numbers corresponding to different years. 48.1, 56.6, 64.0, 71.0, 75.2, and 79.2. And so that was a list, so that's enclosed in square brackets, and then a comma to separate that dictionary entry from the dictionary entry for the next country. Next country is Denmark. And again, we're going to give it a list of values: 51.3, 57.5, 66.1, 72.0, 74.2, and 77.0. Close the square brackets. So that's the end of the list of life expectancies for Denmark, comma, to go to the next dictionary entry. And the last one that I'm going to add is for Egypt. And notice there can't be a space on either side of the colon. Our final one is 32.7, 32.6, 33.8, 46.9, 58.0, 68.7. Okay, so now we have a dictionary with 3 entries: Canada, Denmark, and Egypt. And the values for each of those entries are lists with a number of values within them. Now, how can we access the values inside those lists? Because they're doubly embedded, right? So we have a dictionary that contains keys, so we access the dictionary values through their keys. But what if we wanted to access only a particular value within the list for Canada or for Denmark? So we just use nested indexing, intl life exp. Whoops, sorry. And then square brackets. So we saw this syntax before, Denmark. So this is how you would access the entire entry for Denmark. So if we just do that, we get the whole list of values. But since that's a list, we can add a second index here. And second set of square brackets, and in there tell it what position within the list we want to access. So if I say 1, that'll give me the second entry, because remember, Python counts from 0. So 57.5 is that second entry in the list for Denmark. So we can use that nested indexing to access nested dictionary entries. And the order is sort of from the outside in, meaning that our first specification is for the dictionary key. And then within that, if we want to subselect a particular value, that comes second in our nested indexing. So we can do this with nested dictionaries as well. So I can redefine international underscore life exp as a dictionary, but now each of the countries, so let's say Canada, its entry is no longer a list. We're going to make that a dictionary inside another dictionary. So again, curly braces. And as I did before, I'm going to use years as integers as my keys. So for 1900, life expectancy in Canada was 48.1. 1920, it was 56.6. In 1940, it was 64. In 1960, it was 71. And in 1980, it was 75.2. And finally, in 2000, it was 79.2. Okay, so I go outside the inner set of curly braces, so that's the dictionary for Canada, but still inside the curly braces for the entire dictionary. Hit enter again, so that I can put my entry for Denmark on the next line. And then it's the same thing. And at this point, I am going to just copy and paste those other entries in the interests of time. Okay. For you as a learner, I do encourage you to type these in just because it's good to practice and pay close attention to when you're using curly braces, using the colons to separate keys and values, using commas to separate different entries within the dictionary, etc. Okay, so I'm going to do that, and then I'll ask for the international life expectancy for Egypt. And that returns a dictionary with those values. Great. And the same kind of nested indexing that we saw above also works when you have a dictionary as opposed to a list nested inside another dictionary. So international life exp Denmark. And then outside of those square brackets, open new square brackets and give it the key for the year that I want to access, 1940. Gives me 66.1. And that's indeed what's in there. The other thing I'll point out is that each of the dictionaries that are embedded in this larger dictionary are independent of each other. So although, in a good data set, you might want to ensure that you have entries for every year for all the countries. If you're missing data, that doesn't matter. So you can see I've set up Canada with every sort of 20-year intervals. For Denmark, I only had 3 years in there, 1900, 1920, 1940. And for Egypt, I had 4, but they're not continuous. So 1900, 1920, 1940, we're missing 1960, and we go to 1980. So that's totally fine. You can have very different values, keys and values in each of your nested dictionaries. All right, so that's the end of the lesson per se. Now we move into exercises, and as always, I encourage you to pause the video at this point. Try and work through the exercises on your own, and then unpause, and I'll work through them with you. All right, so our first task is to create a dictionary called Weekdays, in which the keys are the names of the days of the week from Monday to Friday, and the values are the dates of those days of the week for this week. So I'm going to create weekdays equals curly braces to open a dictionary. My first key is Monday. And for me doing this, Monday this week was the 20th. So I'm just going to give it a value of 20. And then Tuesday is 21. And note that my keys in this case are strings. My values are integers. Wednesday is 22. Thursday, 23. Friday, 24. All right. So, having created that dictionary, put the value for Wednesday. So, we just say weekdays, square bracket, and the name of the key that we want. And you can see Wednesday is in fact the 22nd. Now, although dictionaries aren't stored in a sorted format, we can ask for the keys and then run the sorted function in order to sort those keys alphabetically. So that's what we're supposed to do here. So let's, and this is sort of a multi-step problem because we have to get the keys from the dictionary and then we have to sort them. And it's often useful when you have these multi-step problems to do one step at a time, make sure that works, and then add another layer of complexity. So like I say, the first thing I want to do here is get the keys. So that would be weekdays.keys, and then empty parentheses. So that's my .keys method, and it returns the keys. Okay, so how do I sort that? Well, we learned last time that there's a function called sorted that takes an argument of a set of things that you want to sort. So I'm going to put that in parentheses as my argument and type sorted. And now you can see that it's sorted alphabetically. So Friday is not the first day of the week or the first entry in the dictionary, but it's alphabetically first. So we can sort our keys if we want to. Okay, extending dictionaries. So here we want to add new entries to our dictionary. So weekdays, we want to add the weekend days. And so I just add these individually. So weekdays, Saturday as my key, and assign that to a value of 25. And then weekdays, Sunday, and assign to that a value of 26. Oops. I have to make my square brackets in the right place, run those. Okay, we've done it. And then our practice is to remove the entry for Wednesday from the weekdays dictionary. And remember, there's a couple of ways that we can do that. You can use the del statement or you can use .pop. I'm going to use the .pop method. So weekdays .pop. And then the argument is the name of the key that you want to remove. So Wednesday. And for good measure, I'll print weekdays to confirm that that worked. So yes, now we have Monday, Tuesday, Thursday, Friday, Saturday, Sunday. And then this one is practice with nested indexing. So we have to remove the entry for 1980 from the International Life Expectancy Dictionary entry for Canada. So again, we have to think about, okay, how are we going to do that? Well, the way that we access that entry is INTL Life EXP. And we go from the outside in. So within that dictionary of international life expectancy, the keys are the names of countries. So I'm going to say Canada. If I were to run that now, I would get all the entries for Canada. If I want just 1980, I can do another set of square brackets, 1980. And you can see I'm just building up this task one step at a time. Okay, so now I have that. And so now I can pop that to remove it. So how would I do that? I would say International Life Expectancy Canada .pop 1980, like that. Okay, and when it pops, it actually returns the value. So now so that's why it's printed out there. If I say International Life EXP, just get the whole thing, you can see that for Canada, 1980 is no longer there. And finally, we can check our dictionaries to see if particular keys are present. And so to do that, we use the in statement. So again, we can just say print, as we saw before, 1940 in INTL Life EXP square bracket. We want to know specifically if it's there for Denmark. So I'm going to say within the Denmark entry. Oh, and it helps if you type things properly. And then finally, we want to check if the year 2000 is a key in the entry for Egypt in the International Life Expectancy Dictionary. So basically doing the same thing as the last one. So print 2000 in INTL Life EXP and specify this time Egypt. And that's false. So we didn't have an entry for the year 2000 for Egypt. All right, so that brings us to the end of the lesson. Just to summarize, dictionaries are a special type of collection called mappings. Each dictionary entry is specified as a key value pair with the key preceding a colon and then the value after the colon. Key value pairs are assigned to variable names within curly braces. Keys have to be immutable types, like strings or numbers, but the values can be any Python type, including lists or other dictionaries. Dictionaries themselves are mutable in that you can add or delete entries, or you can change the value of any entry. You can add new dictionary entries through assignment, but you can't actually change the name of a key once you've created it. So if you make an error in naming a key, you'll have to delete that key and create a new one. You can delete a key, an entry, including the key and value, by using either the del statement or the .pop method. Dictionaries store their entries in an unordered fashion, so you can't access an entry based on its serial or sequential position the way you could entries in a list. Instead, you access the values based on their keys. Then the length of a dictionary is the number of key-value pairs that it contains. And finally, you can see a list of all dictionary keys or values using the .keys and .values methods, respectively. All right, that brings us to the end of the lesson. Thanks for watching, and I'll see you next time.